Alright, question 12, last question of this chapter. Circle passing through the origin is tangent to that hyperbola at point A, intersects it again at two other points. Prove that the line from origin to A is perpendicular to BC. So let's actually draw this. First of all, let's just draw a generic circle that goes through the origin, which means, I'm going to just do mine there. There's my circle going through the origin. So I'm going to say that if this point is A and this point is B, then its center is A, comma B. So I'm looking at the circle right now. And radius R. Then it has the equation x take A squared plus y take B squared equals R squared. I know it passes through the origin, which is 0, 0. So I can say 0 take A squared plus 0 take B squared equals R squared. So I know A squared plus B squared equals R squared. That's as far as I can go with that circle right now. Now let's look at the hyperbola xy equals 1. xy equals 1. This means y equals 1 on x. So that's going to go through here and here. It says it's tangent at point A, so I'm going to draw one of these a bit better. And I'm going to pretend that that's tangent there. So I'm going to say that this is point A. And I'm going to say these are points B and C. So we have a repeated root at A and distinct roots at B and C. So I'm going to call the repeated root alpha, and I'm going to call these ones beta and gamma. Okay, how can we actually start this question? Well, if I've got y equals 1 on x and x take A squared plus y take B squared equals R squared, I'm going to substitute that for y. So I've got x take A squared plus 1 on x take B squared equals R squared. And I also know R squared equals A squared plus B squared. So I'm going to substitute that in for R squared. So now I've got x take A squared plus 1 on x take B squared equals A squared plus B squared. Alright, I'm not sure what to do, so I'm going to expand. So I've got x squared take 2ax plus A squared plus 1 on x squared take 2 times 1 on x times b plus b squared equals A squared plus B squared. I've got an A squared and a B squared popping up on both sides. So I now can say x squared take 2ax plus 1 on x squared take 2 on x, 2b on x equals 0. If I put all this together with x squared on the bottom, so that's x to the 4 on x squared take 2ax cubed on x squared plus 1 on x squared take 2bx on x squared equals 0. Okay. And then I'm going to multiply out by x squared. So I get x to the 4 take 2ax cubed take 2bx plus 1 equals 0. And this is what we're used to seeing. This is what we're used to seeing. So if I have A is x equals alpha, y equals 1 on x, so it's 1 on alpha. So I've got A is that point, B is the point x equals beta, y equals 1 on beta, and C is the point x equals gamma, y equals 1 on gamma, because it was much easier to sub alpha, beta, and gamma into 1 on x instead of x take a squared plus y take b squared equals r squared. So these are the roots of the quartic, be the roots, so the intersections of x to the 4 take 2ax cubed take 2bx plus 1 equals 0. And this one is repeated because we decided A was where it was a tangent. What do they actually want? Prove that OA is perpendicular to BC. Ah, okay. So the line OA goes from 0, 0 to alpha 1 on alpha. So if I wanted to write an equation for this line, well, the gradient of y equals mx plus b, then the gradient m equals rise over run. So it's y2 take y1 over x2 take x1. So m equals 1 on alpha take 0 on alpha take 0. So m is 1 on alpha squared. And now I'm going to do something with the line, something similar with the line BC. So the line BC goes from B, which is beta 1 on beta, to gamma 1 on gamma. So we have 1 on gamma take 1 on beta over gamma minus beta. So we get, oh my gosh, 1 on gamma take 1 on beta divided by gamma take beta. So that is beta take gamma on gamma beta times 1 on gamma take beta, which gives me minus 1 on gamma times beta. Okay. So they're perpendicular. If m2 times m1 equals minus 1. Remember that? We did that last year. So m2 times m1, here I've got 1 on alpha squared times minus 1 on gamma beta which gives me minus 1 on alpha squared gamma beta. This thing is looking familiar though. This thing here, if I had the roots of the quartic, so the quartic I started with, this thing, we'd already decided the roots of this thing are alpha because it's repeated, beta and gamma. And if we do the product of roots, we know alpha times beta times gamma equals E on A, so it's 1 on 1. So alpha squared beta gamma equals 1. Okay, now I know that minus 1 on alpha squared beta gamma equals minus 1 on 1. Therefore, M2 times M1 equals minus 1. So the line OA and BC are perpendicular. Wow.